bitches, that's my fucking problem. Yeah, I like to fuck, I got a fucking problem. I love bad bitches.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. In a thermodynamic approach, we must identify the system, which is the object of interest, in this case a flask, and the surroundings, which is everything else. And then the study of the flow of energy during a chemical reaction requires that we distinguish between the system and the small, well-defined part of the universe in which we are interested, such as the chemical reaction, and its surroundings, which is the rest of the universe. This includes the container in which the reaction is carried out in this case. And so when we talk about the universe, it sounds like a really vast thing to talk about, like whatever surrounds everything else around us. But in this case, we're just talking about, in this specific example, the entire container and the area in which the reaction is happening. So this is a really important concept, that the system plus the surroundings equals the universe. And then we also need to identify if the system is open or closed or isolated. So let's go through that one by one. So an open system means that both matter and energy can be exchanged with the surroundings. So in an open system, matter can be exchanged from the system, in this case the flask, and the surroundings. On the other hand, if it's closed, it means that energy can be exchanged. So in this case, with the flask example, the inside of the flask can be exchanged in terms of energy with the surroundings. So energy can go in and out, but not matter. And finally, we have isolated, which is where nothing can be exchanged. So just as the term states, when something is isolated, it's by itself and nothing can be exchanged with it. So in this case, energy cannot be exchanged from this flask to its surroundings. So when you talk about a beaker of water, let's say that this is a beaker of water, water can evaporate and the beaker does not insulate it, right? So basically, if water can evaporate out of here, it means that this system is open. Matter is being exchanged, energy can be released, it's just an open system. However, if we seal this beaker of water, let's seal it with, let's say, some paraffin, where it can no longer exchange matter with the outside world, then this is a closed system, where energy can still be exchanged, but water can no longer evaporate, and it's going to just condense back in the normal state. But then if we do combustion of glucose in a bomb calorimeter, remember we talked about the setup of a calorimeter, that means that the system is isolated, where nothing can be exchanged. No energy, no matter, it's isolated, and that's really important because remember when we talk about the bomb calorimeter, delta H is NC delta T. In order for us to relate the number of moles, the specific heat capacity, and the change in the temperature, if heat is being exchanged and coming in or coming out, then the change in the temperature is going to be different from the actual value that we want for the enthalpy change. So there's three ways of changing the energy of a system. First, we can add or remove the amount of substance. For example, in an open system, we can add 1 gram of glucose to 9 grams in a beaker in an open system. So in this beaker, I can just add something, and that's adding or subtracting. Secondly, we can heat or cool the system. And this is an example of a closed system, right? Where energy is being exchanged in the form of heat, where heat is leaving or heat is coming in. But on the other hand, matter is not being exchanged because we're not adding or subtracting an amount of a substance. And finally, we can do work on the system. So what this means is, let's say we have a container and it's sealed / isolated, and we have a piston. Basically, this is like a lever that you can move up or down. When we compress this, the volume inside of this container decreases, right? Volume decreases since we're pushing down the piston. So this compression is going to do work on the system. On the other hand, if we do it the opposite way and we lift up the piston, this is the system doing work on the surroundings because the piston is moving up, outward, into the surroundings, and the volume increases. So this is another example of a closed system, because energy is being exchanged, but nothing is being exchanged in the form of matter. So there's 3 ways of changing energy in a system. Okay, so now let me go through each one. So the first one is for a very typical open system where matter and energy can be exchanged, and it's purely adding or removing an amount of substance. In the system. And so let's say in this beaker we have 1 gram of glucose, and then if we add another gram of glucose, then we're changing the energy of the system, right? Since we're adding something to it. And in this case, matter is being added into the system, and thus it's open. The second way is to heat or cool the system. So in this scenario, this is a closed system because energy is being exchanged in the form of heat, where heat is going in or out of the system and resulting in it heating or cooling, but matter is not being exchanged. The third way to change the energy of a system is by doing work on the system or by doing work on the surroundings. So, do work on system, or let the system do work on the surroundings. And so this is another example of a closed system since only energy is being exchanged. And I'll draw you a little diagram right here, and I'll talk about this in more detail in a second, but let's imagine a container with a piston. So this piston, you can basically lift the lever up or down, and you can increase or decrease the volume. So when you compress a piston, so you're compressing it, and you're decreasing the volume, right? Because this is moving down. Let's say the final level of the piston is here, it got moved down by this much. When you compress it, you're doing work on the system, because remember, this is your system. So work on system. And now let's say we put this in a box and call that the surroundings. Where on the other hand, if we pull out the piston, and let's say that the final level of the piston ends up being this line because you pulled it up, in that case the volume increases and the system is doing work on the surroundings. So system work on surroundings. So this is just an example of how you can change the energy of a system by doing work on the system itself or doing work on the surroundings. And now I'll talk a little more about work and how the piston moving out is going to change the energy of the system.